So, good morning, and I'm really excited to be here. I'm sorry I've lost my voice a little bit. I used to think I had a good immune system, and now I hang out a lot with the toddlers, so I think I was just good at not having people sneeze right here. But I'm really been looking forward to this conference, and from here on out, I will spare you bad puns about anticipation. But I want to start on a note that I really like this paper. And if you're thinking about adding it to your reading rotation, I just want to say that it provides a really thoughtful unpacking of the no anticipation assumption in diff and diff. One that has been the subject of far less study compared to other aspects of diff and diff. You'll note that it never came up in the last shock. And the paper is also very clearly written. So like other papers by these authors, reading it takes pretty complex math and makes it extremely easy for a reader to follow, which is something for which I am always very grateful and that I don't take for granted. So let's start with a brief overview of what exactly we mean by a no anticipation assumption. I think probably everyone in the room is familiar with this picture, which displays the canonical difference and differences set up, where we have a treatment group and a non-experimental comparison group. And our identifying assumption is that treatment and comparison units would have moved in parallel absent the intervention. This is used to impute the treatment group counterfactual and thereby estimate a treatment effect. Oftentimes, we refer to this identifying assumption only as the parallel trends assumption. But in fact, as the authors of this paper note, this identifying assumption encodes two assumptions. And so we'll walk through how we get these in the canonical diff and diff setup with 2 units and 2 time periods, where we have unit 1 treated at time 1. We typically want to estimate the average treatment effect on the treated, which here we're notating in a potential outcomes framework such that the subscript on Y indicates the time period of interest. The 1 in parentheses indicates that this is the potential outcome under treatment, and conditioning on D tells us that this is for the treated unit or the unit with D equal to 1. We in fact observe a sample analog of this first quantity, but we don't observe the untreated potential outcomes at time 1 for the treated group. And so in order to estimate the ATT, we need to add some assumptions on top of this framework. And so to identify the ATT, we first assume parallel trends in untreated potential outcomes, by which we mean that the change in treated units from time T0 to T1 absent treatment is equal to the change in comparison units from time T0 to T1, also absent treatment. In this expression, we have the quantity that we want to impute. And so we can rearrange this expression into this first bit for which we observe sample analogs, and the second term, which is the potential outcome for units with D equal 1 at time 0 under no treatment, which we don't in fact observe because this unit was in fact treated. And so to identify the ATT, we also assume no anticipation, that we can impute this quantity using the potential outcome under treatment at time 0 for units of D equals 1, which says that in practice or in effect, the behavior of these units wasn't affected by knowing that they were or expecting that they might be treated in the future. So these generally are thought of as pretty big assumptions, and we know that diff and diff is this funky space where we are using a functional form assumption for identification, and we have to answer this question of why do we believe that these functional form assumptions are true. And a lot of ink, including some of my own, has been spilled on parallel trends. Sort of first, in the first wave of literature, cautioning against traditional evaluations for parallel trends, which often involve some type of hypothesis testing. And in a second wave of literature, coming up with and proposing several different approaches to address violations of parallel trends through methods like bounding or partial identification, bracketing, and sensitivity analyses. But there has been far less treatment of no anticipation. After I read this paper, I went back to a review paper we had just drafted, and I looked at how we talked about the no anticipation assumption. And indeed, we had a paragraph that basically said the key identifying assumption in diff and diff is parallel trends. We talked about it for a little bit, and they were like, oh, and by the way, you need no anticipation too. But where has it come up in the literature prior? The first is that we certainly describe and observe anticipation effects in a variety of places in the literature. And importantly, anticipation effects can either be in the same direction of the treatment effect or in the opposite direction of the treatment effect. So in the latter case, this often occurs if people anticipate receiving some type of benefit in the future. And so Alpert 2016 looked at drug utilization before Medicare Part D enactment, before Medicare Part D implementation in the 2 years between enactment and implementation, and found decreased utilization of drugs for chronic conditions, but not acute conditions, basically reflecting that people were sort of holding back on their usage, and that failing to account for this would overestimate the impact of Medicare Part D. By contrast, when there are policies that involve some kind of regulation or reform, oftentimes people will start to act as though that exists prior to its actual implementation. And an example of this is with physician labor supply and tort reform. And in this case, not accounting for the anticipation effect is going to make the treatment effect seem too small. The thing about working in diff and diff, though, sort of more broadly, is that you have a lot of very, very thoughtful applied practitioners who are often aware of issues like anticipation and thinking about creative and reasonable solutions for dealing with them. And so I think that, as the authors of this paper note, the most common applied practice that we see for dealing with no anticipation is doing something like what you see in this paper from 2013, which looked at the impact of dependent coverage mandates on insurance status. And what the authors did is they considered the pre-period ending when the ACA was first passed or enacted, and then they measure effects between passage and implementation and following implementation when you're actually measuring an intervention effect. The last place where we've seen some measurement or some discussion of no anticipation has been in discussions of methodological guidance, often geared at the parallel trends assumption. So, for example, Ramachan and Roth, in their approach to bounding violations of parallel trends, talk about Ashenfelter's dip, which is a type of anticipatory effect. Canonical and labor economics related to the impact of treatment programs and sort of seeing a dip in earnings prior to a treatment program as something that you might consider when you're bounding violations of parallel trends. But this is quite limited compared to what you saw on the prior slide. And there are good reasons to want to talk more in a more principled way about no anticipation. The first reason, which the authors raise, which I think stays behind a lot of how we think about, or is behind a lot of the work on diff and diff, is that we worry about misleading conclusions, particularly for no anticipation, the no anticipation assumption, when we're interested in measuring specifically the implementation effect of a policy rather than just the enactment effect of a policy. The authors also emphasize that we might think of anticipation effects as being more complicated than just dropping a few pre-intervention periods. So they emphasize that we don't always actually know when people are going to start to change their behavior in anticipation of a policy, and also that we would expect a lot of heterogeneity in anticipation effects where different people and groups react at different times. And the last thing about no anticipation, which the authors do a really beautiful job of unpacking, but I'll talk more about in the comment section, is that no anticipation has some really interesting and tricky interactions with violations of parallel trends. And so it's worth a paper. And the key contribution of this paper is that the authors propose partial identification approaches to bound the diff and diff ATT under assumptions about the magnitude of anticipation effects. And my talk today is going to briefly describe some building blocks that they use in their analytic framework. Use this to describe the bounds that they derived under different assumptions about anticipation effects. briefly touch on extensions that they propose to include violations of parallel trends and staggered treatment timing and address staggered treatment timing within their bounds. And then I'll provide some comments during which I'll mention the really fantastic empirical examples that they describe. So the key building block that the authors use in order to come up with the bounds that they derive on the ATT under anticipation effects is this theta t OLS, which is the difference between average treatment and comparison sample outcomes at time t. And at time 1, which is the post-treatment period in this 2-period model we're still working with, they decompose this difference into the ATT and a second term, which is the difference of untreated potential outcomes at this time between treatment and comparison groups, which they call selection bias. They repeat this process to get a theta 0 OLS, and then similarly decompose this into an anticipation effect and a selection bias term at time 0, where this selection bias term is the notation coming from Heckman, 1998. Then they note that the canonical diff and diff estimator is the difference between theta 1 OLS and theta 0 OLS, which tells us that our diff and diff estimator is going to equal the average treatment effect on the treated minus the anticipation effect plus this additional term, which reflects violations of parallel trends. And so in canonical diff and diff, we assume that the second term and the third and fourth term, the difference between the third and fourth term are equal to 0. But in fact, we don't actually need this to identify the ATT. We could relax it a bit. But for now, though, we're going to assume parallel trends. And then the bias in the difference estimator is the, from anticipation, is the negative of this anticipation effect. So to use the Medicare Part D example from earlier, if we saw a decrease in usage of medications prior to enactment, this is going to lead to the bias in the diff and diff estimator as being positive or having too large of an effect. With this framework, they construct bounds on the impact of the, excuse me, they construct bounds on how anticipation effects might impact the ATT. So in the simple 2-period case, they say, let's assume a bounded anticipation effect, which means that for some known constant, so some value of C between 0 and 1, the absolute value of the anticipation effect is going to be less than C times the average treatment effect on the treated. So if C is 0, we're back in our no anticipation world, but very reasonably, this is saying we wouldn't expect an anticipation effect that's bigger than the true effect. You'll notice, though, that there are no assumptions on the sign. So they're basically saying we know that in practice, anticipation effects could be positive or could be negative. Because we also assume parallel trends, which tells us that theta diff and diff is equal to the ATT minus the AE, we can substitute in the theta diff and diff into the we can substitute into this expression for the AE, and we can come up with this bound for the average treatment effect on the treated, which basically says we're going to scale the diff and diff estimator by 1 plus C and 1 minus C, and use that in order to construct the upper and lower bound for what we would expect, basically because we don't expect to see bias more than a multiplicative value of C. And if this notation is a little bit tricky to interpret, I'll note just that because C is less than 1, that means that the left term is going to bind and basically be your full interval if theta diff and diff is positive, and the right term is going to do that if it's negative. But writing it in this way is going to be useful for thinking about how we can actually conduct inference on these sets later on. So that's 2 periods, but we're almost never in a 2-period world. And so they very quickly move into thinking about multiple pre-intervention periods. And when we move into multiple pre-intervention periods, we need to adapt both the parallel trend assumption and the assumption about the magnitude of the anticipation effect. So for the parallel trends assumption, they choose to assume a strong parallel trends assumption, which states that the selection bias at each pre-intervention period is also equal to the selection bias and during at period 1. This is a stronger assumption than maybe strictly required for some diff and diff estimators, but it's consistent with how I think we often think about parallel trends, that we would hope that trends are parallel across the whole time series. The second thing they do is they assume what they call exponential C-bounded anticipation. And so they relax the assumption from before to bound the anticipation effect in each period T0. So I'll note that if we're in a case where we're looking at the last pre-intervention period where T0 is set equal to 0 because treatment happens at time 1, we have the exact same assumption as before, but now they're assuming that as you move back in time, the extent of the anticipation effect is going to decline according to C raised to the power of the absolute value of T0 plus 1. So you have a sort of declining anticipation effect over time. The idea behind exponential C-bounded anticipation is that initially only a few people know about an intervention, but they're assuming that sort of progressively more people will learn about it, and then effects will grow over time. And they motivate this through a forward-looking model, which assumes that an individual's treatment effect depends both on their actual treatment at times t, as well as their anticipation looking forward. They derive sort of formal conditions under the forward-looking model, there exists some constant c that would meet this framework. But I honestly found it most helpful to just plot c to the absolute value of t plus 1 for a bunch of values of c, assuming sort of 20 pre-intervention time periods. And what I found really helpful for looking about this plot, once I looked at this plot, were two facts. The first is that it's pretty clear that this covers a huge range of possible functional forms. So unless you think that the anticipation effect is basically equal to the full treatment effect for the full period, you're probably fine with this assumption. And it also really highlights that if you want tighter bounds, if you want to use a lower C, you really need to have most of the anticipation effect pretty closely concentrated toward the point of treatment. But I found this to be a helpful visual for just understanding what they're saying. It turns out that under this strong parallel trends assumption and the exponential C-bounded assumption, we can in fact tighten the bounds that we had for the 2-period model. And we do this by using theta diff DID T0, where now we are constructing a diff and diff estimator using all the different T0s as pre-intervention time periods. Then because we have bounds that hold over each pre-intervention time period, or for each pre-intervention time period, we can in fact take the maximum of the lower bounds over all of these diff and diff estimators and the minimum of the upper bounds over all of these diff and diff estimators. And so we get a little bit of a tighter bound. So at this point, this is like a big part of the contribution of the paper. And we're getting there to actually applying this in practice. It turns out estimation is straightforward, but it's actually usually not super informative, as I'm sure a lot of people in this room are familiar with, to present point bounds. Unfortunately, we can conduct inference because these are intersection union sets with standard methods to obtain a uniformly valid asymptotic confidence set for the bounded parameter of interest. So we can say that in confidence sets so constructed, we would expect the ATT to fall within that set 95% of the time. I think it's helpful, rather than going through the math behind these, to just illustrate what this estimation and inference approach looks like in practice and what you would expect to see. So here's an example that they give in the paper with the data generating process. So the true discount factor here, delta, is equal to 0.5. So there's some discounted anticipation effect. And the treatment effect is random at each time period, drawn from a uniform distribution between 0 and 4. And then there's a measure of treatment status so we're just sort of defining treated units in a particular way and a random error term. And so what happens once this procedure is run? So here's the picture that you can have in your head. Where on the x-axis is C, so that's different potential values you're using to say that the average anticipation, the magnitude of the average anticipation effect is less than C times the ATT. And there's a bunch of different lines on this plot. So under this data generating process, In fact, our estimate, our naive diff and diff estimate is going to be biased. So the top dotted green line is the true ATT estimate, and the bottom yellow dotted line is what you're going to get if you just run a diff and diff. Then the blue line is the lower bound that you get out of this, this inbounding approach, and the red line is the upper bound. So we're kind of happy over in this corner where we see that the upper bound is above the lower bound. But what's going on over here? It turns out that if you pick a C that is too small and you are doing the selecting of the maximum and minimum of the bounds that I described before in the multi-period case, you can end up with bounds that basically rule out the possibility of any ATT existing within that bound. And so C is not estimated, it's assumed, but this gives us a pretty good indication that values of C below 0.4 or 0.5 are not realistic in this particular context. And in fact, we know that the true value, the true value of delta is 0.5, and so we would expect that this bounding approach should work well when we are above the value of C equal to 0.5, because it's a less than or equal to. And so we would hope that once we hit 0.5, the true ATT falls within the bound. And it doesn't do that here, because these estimated point bounds are going to be too narrow. But once we move to the confidence band on the ATT, we in fact now have the ATT falling within these bounds. And so we are now in a world where we can say, okay, we know that probably our data are not very consistent with a model where C is very small, but we expect the ATT to be covered once we move into a realm where we've chosen a reasonable C, and indeed we see that that is the case. The others then hopefully provide a number of extensions to these bounds. I won't go into them in a ton of detail because I want to spend some time on comments, but I want to note that in particular, they do a lot of work to combine bounds on no anticipation with other bounds that you might have or be more familiar with, like bounds assuming violations of parallel trends. So first, they define bounds assuming a violation of either strong parallel trends or no anticipation. Then they define bounds assuming violation of both strong parallel trends and no anticipation. And really helpfully, they extend all of this work to the staggered treatment timing context, which I really appreciated both because this has become a mainstay, staggered treatment timings have become a mainstay of a lot of thinking about diff and diff analyses, and because in the context of staggered treatment timing, we would expect anticipation effects to be especially important. And they also show how in this special case, there's perhaps more that you can learn about anticipation effects than you could otherwise. I won't go into these bounds in a ton of detail, but I'll just briefly note that for the second bound where you relax or allow for violations of both the parallel trends assumption and no anticipation, they assume bias set stability as an alternative to parallel trends. So they assume that the selection bias at time 1 falls within the pre-intervention selection biases. We can talk about this assumption, but that's what we have for now. And then sort of very nicely, the bound actually looks a lot like the bound we had before, but now instead of the maximum on the left and the minimum on the right, we have the minimum on the left and the maximum on the right. So I really like this paper, but I'm going to take a minute to talk through a couple of comments that I had for ideas, thoughts, extensions. The first thing that I found myself thinking about a lot when reading this paper, it was to ask the question, what actually is an anticipation effect? Because sure, we have a mathematical definition, and to me, this feels really straightforward after a policy is set. So when you're in a realm where you have, for example, passage of a law, but you haven't yet had implementation. I think anticipation effects, though, are conceptually a lot trickier when passage of the policy is uncertain, and we conceive of passage of a policy as random. Because in fact, individuals can change their behavior in anticipation of a policy that does not come to pass. And so that leads to an interesting question of what do we actually want to measure? Like, are we hoping to include or exclude those effects? And as written, the assumption that we have is closer to non-differential anticipation between the cases where you in fact ended up treated or untreated. But I spent a little time trying to parse that through. The second thing that this paper made me think a lot was about how we consider the interplay between no anticipation and parallel trends. And the authors do a lot of thinking on this. But for me, I just felt like there were a whole lot of places we could go. I mean, typically we worry a lot less about anticipation as a source of worry. But when underlying trends unrelated to anticipation are changing over time and data are limited or messy, you can really see how you would end up in hot water. And one example is that in addition to being thought of as part of the estimation process, parallel pre-trends are often used for either formal or informal model selection. And so if your pre-trends kind of look bad, it's not terribly uncommon to change your comparison units. But what really sticks out to me from this paper is that anticipation effects are going to stay with your treated units. And so forcing good pre-trends could in fact introduce bias in addition to the other distortions that we see from model selection. So the very toy example is like, let's say we're in a world where we have unit 1, so you have a flat slope for a couple of periods, and then the slope of the line changes. In applied practice, I don't think it would be terribly uncommon to say, well, let's start the pre-intervention period at time 4 and use unit 3 as our comparison unit. But what if unit 1's effects and change were a consequence of anticipation? The last sort of set of questions that I have for the authors just relate to the sort of canonical question that I think we have for all methodologists, to the question that Melissa had on our paper as well, which is it's sometimes hard to know exactly what we should do in practice. And so here are 4 questions that arose. The first question I have is like, when do we quit? We have a lot of methods that are trying to deal with small violations of parallel trends. And I think that often begs the question of like, how small do they have to be for us to keep using diff and diff? And when do we just say like diff and diff is not an appropriate method to use here? So not a question just for these authors, but I think a question that is sometimes on my mind as we think about conditioning and bounding and running a bunch of analyses to account for observable differences. The second thing that I had more specific to this paper had to do with the comparison with traditional approaches. So how should we think about the benefits and drawbacks of this kind of bounding analysis compared to the more traditional approaches of like dropping intermediate periods? And I think there's sort of 2 issues to raise here. The first is a question of power. So usually with these bounds, we can either be choosing a small c or a larger c. And we're going to have a much larger confidence interval as c gets larger. So these points are small, but you can see that the confidence interval is getting larger and larger. What I thought was really interesting about some of the applied examples that the authors explored was that in some contexts and for some Cs, the power that they had or the width of the confidence set was smaller than the confidence intervals that the authors estimated, sort of using that last pre-enactment rather than pre-implementation time point as the end of the pre-intervention period. So I would love some thinking about like, what are the pros and cons? Are there pros and cons to these different approaches in terms of power? And how does that vary with different levels of C? More on that in a minute. Second thing is like, what do we do when these approaches yield different results? Like, should they be the same? Might they be different? And the last thing I want to highlight is that both of the authors' empirical examples are cases where there was either an announcement or enactment of a policy, and then a long delayed period before implementation. But I think I'm really curious for how we might think about anticipation effects when there is less of a clear event that tells us about the time period of enactment or notice. So how do we think about anticipation in those contexts? Because it's really easy to just say, well, I assume there's no anticipation. Like sort of 2 remaining questions for what we should do in practice are first related to choosing C. So this C is how big we expect an anticipation effect to be. And to their credit, the authors do note that we have some ideas on how to choose C. We want to get bounds such that the lower bound is lower than the upper bound. And we have some information, for example, about policy timing that can help us to choose C. But I'm also really curious, like, is there a good baseline? And what I was going around in circles in my head thinking about is like, is there any way to measure these types of results or the magnitude of this type of parameter empirically? The last thing I want to emphasize in this context has to do with any difference in differences analysis. which is, I think it's really, really valuable to do bounding analyses because we can see where our results break down. But at the same time, we can always break our results. And we know the world is a really uncertain place, but at the same time, people have to make decisions today. And so I think the last point that I want to highlight in the context of this paper, which I don't expect you to get up here and be able to address, but I want us to keep us in our heads today, is that even as we strive for econometric rigor, how do we translate the bounds that we might come up with into a specific threshold for action? But overall, I just want to say thank you again for a really great paper. I had a lot of fun reading it and talking about it, and I'm excited to hear about how you think about it as well.
Right. Well, good morning, and thank you so much, Alisa, for a very wonderful presentation of our paper. I'm always happy, to hear the take of a non-economist on a different literature, and Alisa has definitely been doing some really good work in this area, so she's the perfect discussant for our paper. So this was really great. In fact, I learned a lot, and I'm really excited. So I don't have any slides prepared, but I think I have some comments and some responses to some of what you raised. I will provide some background to how we came to start work on this. And some of it, I was working with Desiree on with Hill on a project about measurement of treatment in different settings. And one of our meeting was motivate how measurement error can arise in different settings. We said, look, there are some folks when they see an announcement there, policy, and implementation data report the harvest data, who simply blockade their treatment. And so we were studying that sort of scenario as, hey, that's measurement error, because treatment occurs at some point and you backdate the treatment. So if you look at the simple effect model, there's a indication where you multiply the post and the treatment indicator, then result in a case where you have measurement error. And people will push back and say, no, we know there was an announcement 3 or 4 years before, and so it's valid to sort of begin the pre-treatment period by backdating treatment. And so at that point, we'll say, yeah, well, but the assumptions underlying your different names said there's no anticipation. So what do you mean that is, effects occurring before, and how is that consistent with the estimates you provided? And so when we kept wrestling with people on that front, then we said, look, there is a second question here which has to do with the general issue about anticipation, which we need to separate from measurement error and sort of attack that more carefully, And so that's what has led me to this paper with Desiree in general. The graduate student has done a lot of work on this paper as well. So that's the background. So this is really fun to work with, and it's really also brought to light how powerful it is to think about multiple assumptions and their applications on point estimates. And maybe that in some cases bounds may be the way to go. So that's sort of my big takeaways from this work is like maybe the bound exercise may be where to go. So in terms of the first question of when do we quit? Well, I think in most cases that's going to be very case specific, but I'll say before you quit, it might be useful to pursue some boundary before you quit. So I feel like there's a strategy where you have a different diff setup, you immediately could get point estimates, but there are ways now where actually before our paper, you can relax powertrains to provide some bounds to see how important the violations are to powertrains. And we simply said, well, you can provide bounds to that suggest that there could be violations, no anticipation, and your bounds will be robust to both of those. And you can see how wide they are, you can see whether you think it is worthwhile to keep pursuing the project, But yeah, I agree. Even beyond providing those bounds, you may decide to quit if you're just unsatisfied with sort of what the bound exercise provides. And we do definitely need to do a better job of comparing our methods to others that exist, especially in the area of relaxing powertrains. That hasn't been something that we've done yet. It is easy, as you noted, use cases or examples where there's an announcement date and also an implementation date, because then in some ways, as we do, which I know you haven't discussed, but in the second empirical example, is that, well, when you know this announcement date, it is possible that you can, in fact, in those contexts, estimate anticipation effects. So your goal there will be what the effect of announcing this policy at this time, and just essentially the believe our friends can sort of show what the announcement effect is. So in those cases, we know an anticipation effect exists, and we can sort of show you the graphs for that, and show you the effects for that. So we felt that it's easier to demonstrate our methods in those contexts where you can then provide our bounds for the case where you use the implementation date as a way of capturing the implementation effect. And then, of course, our bounds will then sort of account for the fact that there was anticipation. And so you're right, it's sort of like one of the convenient sort of use cases to pick where an announcement date, in most cases, when agents react to it, will suggest they do in fact exist. And so then sort of makes our work easier to demonstrate. But you're right that in general, there may be other examples where it's not as clear that you have an announcement date, but agents may be forward-looking, and so can also sort of anticipate, that will be treated later, act on that, and you could even have different examples where different units are sort of responding ahead of time, at different times. So you're right, it may be better that we go beyond just thinking about these sort of easier, convenient cases where we can empirically show anticipation effects. But as of now, those examples are sort of easier to sort of make the point. But it's more a general point about thinking broadly about anticipation effects. How do we choose C? It's an interesting question, one that we've thought about a little bit. I know the easy answer would be to say, look to the literature to see if you have some sense of if we can know what C is. That's unlikely to be the case in most scenarios. So I like sort of the scenario where you produce the bounds for multiple values of C. And what that leads to essentially, as you pointed out, maybe I'll go back, as you pointed out, is that you could, in fact, then get to a scenario where your bounds that you construct in this case when the upper and lower bounds flip are going to tell you values of C that are inconsistent with the model of anticipation that you assume. So in some sense, I like this idea of the figure on the right side here, where if you do the bounds for different values of C, then you can clearly see potentially that the data may or may not be consistent with the presence of anticipation. So I like to see a graph of this sort where you sort of reproduce these bounds for various values of C, but there could be other ways. There could be other ways to sort of think about how to choose C in this context. But also the last question is obviously much harder to answer. What do you care about? Do you care about anticipation effect? And we take no stand on whether you should only care about anticipation, a combination of both, whatever. So I think that is a question that a policy maker or a researcher might answer for their specific case. It is interesting in some cases to be able to separately display them. It might be interesting in other cases to see sort of what the combined effects are. So that's definitely one that's open to more questions. But certainly this has been and is continuing to be a very fun project to work on and just sort of thinking about how anticipation plays into one of the very popular methods that we use. So thank you very much for all of the wonderful comments. I think I'm certainly going to find a way to steal your graph there about the C. It's really nice to see that and visually present what the C looks like in terms of what our assumption about the exponential C bounded anticipation looks like. So thank you.
Questions? I really like this paper because it made me think about topics I don't usually consider. And the one confusion I had early in both of the presentations was whether you were trying to make this generic to both stock decisions and flow decisions. And as an example, when the government's thinking about policies to encourage like buying an electric car, EV car, you could either have a subsidy to do it once, in which case people would want to delay doing it to buying it until after the policy is in place, or you could have a subsidy of per month, we're going to reward you for owning a car. And that would have a different effect, where maybe I'm willing to buy it earlier because I know I will eventually have greater benefits in the future. And I think some attention to what type of policy it is would change the way you would think about anticipation.
That's exactly right. Most of this sort of frame like the first case in criminal, not a full decision making. But yes, no, thank you. That's good to think about.
So if you assume if you assume there are parallel trends, and then imagine you had like a period specific kind of treatment effect in the periods leading up to the treatment, like the anticipation periods and the post periods. Could you try to estimate C from the time path of the like estimated treatment effects, or do you always have to impose an assumption about C in order to create the bounds? What would it?
I'm not sure that you could still estimate the C, even in that case. And I think and that's why rather than imposing a particular choice of C or attempting to estimate it, I think the way we thought about it is sort of just coming up with some sort of grid where you are able to sort of produce the bounds at for various values of C. Maybe there's a way to think about being able to now one thing, maybe this is probably what you're getting at. One thing, the extension that we haven't talked about here is the case where you have a target adoption framework. And so what we are finding out and what we are working on there is that actually in that case, it becomes possible to provide a testable implication of the no anticipation assumption in that context. So suppose you assume that before anybody gets treated, then there are no anticipation effects, but you allow anticipation effects at least when one group gets treated, then in that case, you would be able to provide this testable implication where you write extended to effects specification and allow the the coefficient on the group specific time effect to change all the way through to the end of the period. Then then you can sort of provide us a test for whether anticipation exists or not. And in that case, you can also then provide evidence for whether the data is consistent with our assumption or not. So I think maybe where you're going is actually pushing us to be able to think about that context where in fact the data may be able to reject whether the anticipation assumption is valid or not. And I think that's an angle we want to pursue more because I don't think that even in the second literature that they usually allow anticipation to be possible within that framework beyond the period where at least some users receive treatment. So that's my best case of how we can begin to sort of allow for the data to drive us to figure out whether anticipation exists or not is the target adoption setup, where it makes sense that when some people become treated, then it is easier to sort of conclude that anticipation may be happening than when nobody has been treated up to some period of time.
So I'm going to tell a story in which I think all of this falls apart. And just to back it up, I think the issue is that there's all kinds of possibilities. There's interactions between kind of no anticipation and the parallel trends. And you can always place some formal assumptions, but then I can kind of tell you a story so I'm going to tell you one story, right? Which I think goes back to this. And, so imagine that you've got a law, you've got the conversation starts happening a few years earlier, and your argument is, well, before that, nothing should have happened in terms of anticipation because you didn't know it was coming. But maybe there was an Ashen factor dip before that, which is what got which is what got people look at it and go, oh, we need a law. And now we're going to have that conversation, right? So you have Ashen factor dip before the kind of the period that you're calling anticipation. And that's going to make that trend non-monotonic too. So the functional form that you pick, which is very flexible, is still monotonic. And I can think of a story where it's not monotonic, but in fact the sign switches from before to after, right? I don't know that I have an answer. I guess this is in some sense deeply philosophical, but we all live with it. I'm going to go back to the argument that at the end of the day, we need an answer in this room as econometricians. We don't ever have to answer a question. We can just show 50,000 different results. But in the policy world, they care about one answer, and you're gonna have to lean in and say, here's where it is. So I'm gonna go back to theory. Right? I mean, you need to have a theoretical foundation for all of this stuff. That we've hidden the parallel trends assumption here, but that's untestable too. And in the data, I think there was a sense that, well, maybe I can just do an event study, right? Get an estimate for every time period. But that also hides and confounds all of these things. So I think you have to lean back to theory and say, here's what I think the world, that's at the stage of the first paper. It was an attempt to sort of bring the theory to the data.
No, I agree with you. This is why the Millennium Red paper was a really nice example of, the forward-looking model, where of course, in that case though, I do want to point out that to make it tractable and, estimate, you have to make some parametric assumptions. In fact, they assume that anticipation effect is in fact equal to the discounted, average treatment effect in the period before. So in that sense, still got a model, but still imposes some sort of strong assumption there. Where in this case, we are simply assuming that the anticipation effect is sort of bounded, above by its discounted ATT. So, again, different model choices, and in that case, assume that, then realize assumptions to sort of this estimation. And in fact, we show that given that model that it has, given that model combined with the potential outcomes framework with parallel trends, that implies our exponential bounded assumption. So, we have thought about this, but when we realize that, and this is why, again, I think it goes back to this question about, partly theory, but also partly the current prescription of if you observe validations or pre-trends, that implies some validation of just parallel trends. Our point is that it's here because you could have also parallel trends and all validations of anticipation. In fact, the Malayan rate exactly point out that so I think to rightly raise the point about modeling, and I think some people already have attempted to do so, and I think this is complementary to that view of sort of thinking about the question and estimation. So we do, I think, it's hard about incorporating potential of other theoretical frameworks for modeling anticipation. If we do just have this forward-looking sort of setup now following Malania rate, but I think there's potential to include other theories about how anticipation might arise in the paper as well. But it's a fair point.
Last question.
Thank you for this. This is, as Randy was saying, made me think a lot, and I actually sent a message to my co-authors, and I was like, we need to think about anticipation in our paper. As a practitioner, I think something that would be really helpful is sort of related to this earlier point. Like if you can lay out types of anticipation, like stories where this does and does not work. So like one question that I have, right, is I'm thinking of like ways to break this. And so, I can think of a story where the policies, we're gonna ban something, right? Say they have a ban for birth control, people stock up on it, right? I think there's like this monotonicity question, but it would be really helpful for practitioners if you just list out this applies for this kind of anticipation, and these are the things that will break this. And, basically just like, this is when you can use it, and this is when there's more, see our next paper.
Right. Yeah. Well, that was an excellent point well taken.
And absolutely, I think it's a fantastic point that we should all be so lucky if all methodology papers came with, here's when you should not try this. So thank you, Austin. So thank you, Alyssa. Thank you, Shul. And thank you, Alyssa and Melissa. I'm gonna get that tongue-tied for fantastic discussion. So we got about 20 minutes. So let's all recaffeinate, and then we'll give ourselves econometric whiplash by switching from diff and diff to structural work.